Hello, everyone. Hello. Okay, so we are just waiting for people to connect. I see we already have 18 watchers or viewers. So we are going to wait just a small amount of time and we will start. Okay, so it's noon, so we are going to start. So hello everyone, welcome to this webinar with René here and Hira, which will have for subject Kafka and Spark. So I will let them present the subject later on, but before that, a small presentation of the context, so of data scientist, in order to tell you what it is about and what we do as a company. So I will give you some numbers to start. So data scientist, pretty much, I think you guessed it. It's a training company oriented towards data. So it was founded in 2017. Right now, we have 120 members with 35 data experts, and we trained a lot of users, as we can see, already 10,000 and only, or at minimum, if I can say, 3,500 on the last year. We offer different courses on almost every subjects in the data ecosystem. For example, data manager, data analyst, data scientist, data engineer, ML engineer, etc., etc. So today, pretty much the presentation is for data engineers or machine learning engineers or data scientists, which would want to have this engineering aspect to the job. So as I said, we are here today with René and Hira, who are experts and leading machine learning experts, even more in the German, in the German ecosystem. So I will let them present the subject and the webinar. Up and up.
All right. Thanks for the introduction and welcome to everybody to our webinar about real-time big data streaming with Kafka and Spark. As Dimitri also already mentioned, we have several projects in industry in Germany. We applied both techniques. We will dive shortly in there to give you insights what we had during our practical settings in the projects, give you tips and show the basic concepts and why it's important, the big data, and also Kafka Spark. Then we come to our introduction. We will also do it together, Hira and me. Hira, do you want to start with your introduction?
Yeah. My name is Hira Akram, and I'm a data scientist at DataMix. I have over 4 years of experience in machine learning and data science. And over the course of this experience, I have had the opportunity to work on different big data technologies like Hadoop and Kafka, and I'm looking forward to discuss those with you.
Right, and I'm head of study programs, digital technologies, and coding at Macromedia University. Like this is 50% of the time. Then also we have where we're working. It's a IT or data science consulting company, DataMix. And also I'm making online courses with over 50,000 participants and also working like 15 years in the area of data science and engineering. A little bit about our projects, company which is behind, like BSH, Dynamics, where we build up data pipelines with big data and also real-time engineering. Don't want to dive too much here. In this, we concentrate on the content. And also we have some publications, we're doing conferences, podcasts, online courses. Can you jump over? And then what we do today is I will present importance of real-time data processing, Apache Kafka. Then we will switch importance of big data, Apache Kafka, PySpark. So why is it important? Real-time, of course, the faster you get the information, the faster you can make predictions in data science or machine learning, predict things. And the faster you are, if you're faster than your competitor in the industry, then you get more revenue, you can save faster costs. So I think it's a crucial, this faster results also in AI. Also Andrew Ng and famous people also mentioned this trend to going more and more in direction of real-time processing. And then also mostly you have big data or projects which we are do. So we telling you about the importance of big data. We're using normally PySpark, Apache Spark, showing you a short introduction, and then bringing both worlds together with the integration of Kafka and Spark, because you get the real-time streaming and you get processes. And this is quite a tricky part. It's not so easy. Always you have some technical issues or challenges, let's say, which you have to solve, and we try to give you here a big, nice overview and picture. And then we have the use cases, best practice, and afterwards also here we'll give the demo. We make then hand over to the importance of big data. And maybe also some advice. If you have questions, then please also put it in the chat, or I don't know if you can tell it, but please put it in the chat. We are very happy to answer you any question. Also, we follow it, so maybe we don't answer it immediately, but once we see it and have a small break, then we dive in directly. So what is the importance of real-time processing? Like, for example, you have cars. One example would be LK with all the traffic data. Then you have to create alerts, traffic jams. You need maybe to monitor where are mostly traffic jams or which hours you can take better. And you also want to avoid these traffic jams, then you need in real time. And that could be that you have a lot of sensors, for example, cars, vehicles, send it to Kafka in the middle. And then on the right, you consume the data and can use it, build your dashboards, monitors, alerts, traffic jam, take a different route, calculate best way, and so on. And then why to take Kafka? First, Kafka is open source distributed. There's also an enterprise version from Confluent, but you can also use it open source, or if you have cloud service like AWS, it's called MWAA. It's I know it's also Kafka MSK called AWS MSK. You get it hosted directly on cloud platforms. And the benefits from Kafka is that it handles a large volume of data. It can scale horizontally. You can put different servers in parallel. It has a high fault tolerance because you have a replication. You replicate the data which is incoming on different nodes. And if one node or server is failing, Kafka still continues working, sending data. And this is also important if you have real-time data, it's crucial at times, so you cannot allow failures. That's why you have replication. And also if you have scale ability of data, you have a lot of mounts, so you also need to scale, and something often can happen. So these are the main benefits of Kafka. How is it organized? On the right, you see, or there's some specific words. Normally you have a producer. This is just the entity which is producing data. It can be a car, it can be a machine, anything. And then it's sending this to a Kafka cluster. And Kafka cluster, it's fault tolerant. It have different servers below. And it's sending it to one topic in a Kafka cluster. You could have one topic for trucks, maybe one topics for cars or for different brands. So then you decide this organize in different records. Or it's like a table. If you think about a SQL database, you have table customer, table employee, the classical. So you create each topic for each table, which you could imagine. And afterwards, you have the consumer. These are then the entities who take the data. You can have maybe department creating the alerts. You have other department which makes a long-term analysis, and also where we come later. One consumer could be then Spark to put it to a big data cluster, keep 3 years of data, and then analyze maybe the traffic jam always on Monday mornings. It's the most crowded, avoid this, then you can also make this long-term analysis. Yeah, we have this replication so that for failure tolerance, producers and consumers. All right, then another example before we had the traffic, but you also could imagine that you have household devices like different machines. You have a TV which is creating messages. You have maybe a smart home device or Alexa, home assistant, a coffee machine, and everything. Every entity is producing. So this would be producers and sending it to a queue. First message which arrives in your queue is in Kafka, and then you have consumers, maybe an app which is telling you your coffee is ready, or putting on the heating machines, or recording some TV. So then you have different consumers, and they subscribe to a topic in your Kafka queue, and they take out then the information and making calculations. All right, and then later, I think we do the demo at the end, Hira?
Yeah.
Yes.
Yeah, that's
So,
it.
yeah.
Screenshot.
So then we go through now with a little bit theory, and then we dive in doing this setting up. Here you see on the top, just that you get a feeling how to set up a broker at the beginning, and to create a topic. And then we will, in the example later, show you how to produce the data and to consume data with PySpark to see the complete end-to-end pipeline from beginning to the end. And then I would hand over to Hira. If you have some questions for Kafka, then please let me know. Of course, there's many things to discuss in Kafka. To give you many examples, I think we want to make a complete end-to-end example that you get an overview, that you can dive in to the topic and then learn in deeply. I think there's to make, for example, a complete course to dive in then Kafka and all these topics, but to get your first big picture from real industry cases. All right. Then I would hand over to Hira.
Yeah, so thank you, René. Now that we know that if we need Kafka to ingest the real-time data, then the question is, why do we need to, what is the value that the data holds? And that brings us to what is the importance of big data, and why are we interested in storing this data and then analyze it possibly. So a few examples could be that the values that big data hold is companies can have data-driven decision-making policies where organizations will make informed decisions based on actual customer data rather than just intuition. And it's also beneficial for the companies to improve their customer experience such that they're getting customer like all the details of the customers and customer related data, so they can personalize the records, let's say the recommendations based on your search history or of the sort. So this is something that can also add value to the business. And lastly, there's predictive analytics. That means that you basically utilize this data and build machine learning models, deep learning models on top of it, and then make predictions possibly to anticipate what future events would look like. So to be able to actually analyze this data, that's where Apache Spark comes into view. So Apache Spark is basically an open source engine for storing and processing large scale data in real time. So once you have your data stored somewhere in using Apache Kafka, you will then be able to analyze this data using Apache Spark. So the benefits are that it allows you to interact in different languages, like you can utilize R, Scala, Java, and Python for data scientists, of course. If you're only familiar with Python and you want to work with large-scale data, then this is where you can actually perform analysis on your data. On top of that, Spark also provides you with querying your data. That means that you're actually getting real-time data, and you're possible to query it, like run SQL queries on top of it to extract data based on your business definitions in real time. And also it's faster, and it supports both batch and real-time data processing. And last but not least, it's fault tolerance. So that's mainly about Apache Spark. Then we have the components. So there's Spark Core, which is the main engine that allows you to parallel process or allow distributed computing. And then we have Spark SQL. This is where the SQL scripts get like you can query your data based on SQL script, and you basically store your data, and then you're able to extract results based on your SQL queries. Then we have Spark Streaming. This is something that we will look into in the live demo. This allows you basically to process real-time data in batches. And then we have MLlib and GraphX, which allow machine learning model or graph processing frameworks for large-scale data. To understand what Spark basically is, the fundamental unit for element collection for Spark is RDD. RDD is basically resilient distributed data set. It's a type of data set in which is fault tolerant, and it is also distributed across the clusters. But the features are that it's lazy, it performs lazy computations, it is slower, and it's persistent. But to carry out more efficient performance, like to have more efficient results, there's something like you will want to work on data frames like similar to Pandas data frame. So which brings us to PySpark data frames. So PySpark is basically a Python API that allows you to utilize the computing and the distributed computing of Apache Spark, and work on the large scale data at the same time. So you are already familiar with Python, you will be able to utilize the compute of Spark, and this way you will be able to work on large scale data. Like in Pandas, you're not able to actually perform analysis on data sets that are way too large. So this is something that PySpark data frames will allow you to perform analysis similar to Pandas. So you can think of PySpark data frame as a Pandas data frame, but this also accommodates a lot of data. The benefits are that it integrates with the Python ecosystem. You can run PySpark scripts on Jupyter Notebook, and this way you can like run interactive scripts. We will look into this in the demo. Then it's easy to use, scalable, and versatile. It allows a lot of different types of data sources. You can use JSON files, XML files, CSV files, or any of the sort. Once you have your application set up and you now have, let's say, a new data source, which is providing you data in CSV format. So you will be able to scale up your project and integrate that data source as well. So this is something that is going to make your application more dynamic to changes as well. Now that we know that Kafka allows you to store data and then Spark allows you to process it, we see that the entire big data ecosystem looks like something in 4 stages, where the first stage is where you are ingesting data in real time using Kafka. And then you utilize Spark's compute to fast and parallel processing to analyze the data. You will then be able to, let's say, perform an SQL query and analyze the data or perform any type of aggregations on top of it. And if you wish to store that data in a semi-structured or structured database, you will also be able to do that using PySpark. And you can save the data in the database, and the database can then be integrated with any BI tool, let's say Tableau, which allows you to create interactive dashboards. So this way you have like an entire end-to-end real-time interactive dashboards where the data is being like if you see event producer 1 at your extreme left, what happens is that events are being produced in real time. They're being ingested by Kafka. They're being transferred to Spark, which then allows them to be stored in a database, and that can be then connected to a dashboard, and you can see live interact with your data in real time. So this is a common practice in a lot of big tech companies. They're not only generating big data, they're also making use of the big data, and this allows them to further enhance their businesses. Like there are a lot of use cases like the real-time analytics, which basically, like I said, you can create interactive live dashboards, which these visualizations will get updated in real time, and this will give you a lot of insight about your data and the activity of the customer. Then we have sentiment analysis. Let's say you perform you carry out any activity on your social media platform. That event will be stored somewhere, and then this event can then be analyzed by these tech companies, which can provide you recommendations. That's why when you let's say search for something more frequently, this will be updated in real time, and you will see the similar recommendations in real time. So this basically enhances the customer experience as well. And then we have fraud detection. That's from a security point of view. You see some suspicious activity on your social media account, and you get the notification in real time. Or you see some suspicious transaction on your bank, and you can like contact your bank and tell them to like you can report to it. So this also has a lot of benefits, not just from the business growth, but also from a security perspective. Now let's look at some success stories that we have here at Datamix. So we had a retail client that provided us with the customer data, which included all types of customer activities, ranging from customer interaction with the website and so on and so forth. So what they wanted was to detect whether the activity was actually carried out by the customer or was it a bot. So it was like a bot detection binary classification model, where what we did was we ingested their data in real time, and then we trained our data on the historical data, trained our model on the historical data at first, and then we were able to ingest the data real time and update our model so that we will provide recommendations in real time whether the activity was actually carried out by the customer or was it a bot. So this actually helped us achieve approximately 90% accuracy in bot detection. So we were able to report whether the activity was actual genuine activity by the customer or by a bot. Similar to that, we had another pipeline set up for them, which allowed them to make better recommendations for their customers. The data that we had already coming in included things like the click history, the website activity, purchase history, or things that were added in the cart or and not purchased or possibly purchased. So we had all type of data activities that the customer carried out on the website. Now this basically help now we provided this information through our Kafka and PySpark pipeline. That's how we basically gathered these insights and provided this information to them so that they can improve their recommendations and provide more precise recommendations to the users. Let's say if somebody is viewing some item multiple times, it's possible that they will be able to purchase, and this is basically going to increase the sales. So these are effective marketing strategies that can allow you to improve your business. Now, let's look at the best practices that we have for Kafka. So for Kafka, basically, partitioning is really very crucial, right? Like René mentioned. What happens is that when you're storing events, you can store them based on partitions. Let's say you partition your data based on date. You will be then able to retrieve this data by filtering out on a data based on that date filter. So this This not only allows like efficient storage, but also allows you to retrieve your data efficiently. Then we have the retention policy. This very much depends on the company policies, like how much retention, how much data they want to keep, and how much they're willing to let go. And since Kafka allows real-time data processing, what happens is that, let's say they have a 1-year window, they will then process the 1 year. They will keep updating and adding new data streams for in real time, and excluding the historical data stream such that 1-year window is retained. So this is like a retention policy that allows you to manage your resources better. And then we have fault tolerance. This is like the replication factor. What happens is that you can decide the number of copies you want to make of the same data set of the same event, so that in case of a broker failure, a server failed, you will still have access to the data, and this prevents data loss. Then we have best practices for Spark. So this we have Spark streaming configurations. This very much depends on the application itself. It allows you to optimize your resources so that you can decide what bad duration or memory settings you want for the application. And this can vary from application to application. And then we have resource management. So there are a lot of cluster management tools like Yarn and Kubernetes that allow you to manage your resources better, like the executor memory, the core, the number of executors, and so on. This can also provide a better resource management and this is like very crucial for you to when setting up a large scale application. You would want to manage your resources. Now let's take a look at the demo. This is going to be a so what we have here is we already have our Kafka broker and a topic set up and running in the backend, like René showed in the screenshot. Now what we have here is a code for a Kafka broker producer. And like I said, producer is going to consume data that is being produced on a certain topic. We have a toy data set here. And what we're doing is that we are creating live streams of data. This basically is going to send. Is my screen visible?
Yes, it's visible. Maybe there was one comment, if you know. I just saw it it's on the right on the comments.
Sorry, I couldn't see the comments.
I was also in the other chat first, so I only saw it now. But question is for everybody also, set up Kafka. Yes, you put it down. Great. Set up Kafka and manage the connections between data sources and data targets needs a data engineer skills level or DevOps. Yes, I would say if you're going for this data, you need it's more about data engineering to get the data connections, to manage it. It's a little bit before data science that the data scientists can use it. So it's more data engineering.
Yeah. So what's happening here is that you're basically generating live streams of data. After every 2 seconds, you're sending a new row to this topic right here. Now you're going to set up a consumer, which is going to consume this data in real time. As the data is being generated there, we are consuming this in real time here. This is how the producer and consumer works at the back end. But then you would want to analyze this data. So for that, what you can do is you set up a Spark session. Then you basically, so you set up a Spark session. These packages might vary from your system to mine because they depend on what your system requires. So once you have the Spark session ready, you will then be able to stream, fetch these live streams of data. What's happening here is you are basically fetching the live streams that are being generated on this topic right here. You can then write these streams in a table this table right here is query data. You're writing these streams in a table. You can think of it like an SQL table as well, because you will then be able to query this using Spark SQL. Yeah, so as the data is being generated, these things are being these rows are being populated, and out of all the data, let's say you are interested in just one column, so you can also filter out that column and perform aggregations of the sort. As you can see, there are values right here, but and the data is being generated in real time. After every run, these values will get updated, which means that we are getting more and more data as the process is running at the back end. So this is what a very basic pipeline would look like, but of course it would be also possible for you to utilize this data to perform machine learning, or to just extract more valuable insights from the data, like I showed we have done at DataMix here. Yeah, so thank you for that. Thank you for listening and all. But here we have a few things that are exciting things that we have at DataMix. We have these podcasts that are mainly centered around data science, and we have industrial experts coming in.
Here there's a question. Can you jump back to the Jupyter Notebook, please?
Yeah.
I think it's a little bit smaller. Maybe we can. Can you dive in? Like Control plus to make it larger, because it's quite small to see.
Okay. Sorry.
Yes, a little bit more larger. Yeah, a little bit more. I think one more, then it's.
Sorry. Yeah.
Yes,
Is this fine?
like this. Yes, now it's fine. Maybe to go through. I think we have some time left.
Yeah. Yeah, I'll go to the notebook again.
The big topics, if anybody missed it from the points.
Yeah, so like I said, we have the Kafka server running, and we have the topic created at the back end. Now, what we want is the producer to consume, to fetch that, the data that is being generated on that topic right there. So we will initiate this once more. This code right here is basically fetching all the records that will be, it's basically a Kafka producer object. And now if you link it to a topic, you will be able to fetch the data that is being generated on that topic. So basically what's happening here is that producer is fetching all the live streaming, it's basically creating live streams of data right here. So we're getting, after every 2 seconds, you're sending one row of this data frame to this topic right here. Now, the data is being produced, but we want to consume it too. So for that, we will have to set up a consumer. This is how you set up a consumer object. You define which topic to subscribe to, which server you're running. This could be multiple servers, and in our case, we just have one server running at the moment. And right here, when you fetch the data from that topic, you will see that as the live streams are being generated, they're also being consumed right here. So that's how a consumer producer functionality looks like. Now that we have the consumer and producer, we are also interested in analyzing this data using Spark. So for that, you will have to set up a Spark session. This is going to take some time. Yeah, you're going to set up a Spark session. And once you have your Spark session up and running, you will want to read these streams. You will have to specify your reading streams from which server and from which topic. And there are other configurations that you can set. This tells you that you're looking for the latest records. This could be also earliest, and so on. So once you have you're reading your light streams here, and now you're writing them to an SQL table, let's say, and it's a table that's basically going to be written in memory. And now you will be able to perform SQL queries on it. What we're doing here is that it's just an SQL query, which is fetching data from this table. And we were storing the data in memory on this table. Now, as the data is being produced, it's also being inserted into the table in real time. And right here, you can see that you have a lot of columns, but just for the analysis purposes, let's say you're just interested in one column, you can also extract data just from that one column and perform analysis or aggregations on top of it. What I was showing here was that as the data is being populated, these numbers will also change in real time. So that's basically how the numbers get updated in real time, and like an end-to-end process of how the live real-time data is being processed.
All right, then.
Are there any questions?
Can you jump to the thank you slide, please, and then go through the questions? Yeah.
Yeah, thank you so much for listening. Now, do we have any questions?
I think there was a question about the language of the website, but it already got
Okay.
answered.
Yeah, this will be solved. So please feel free to reach out to DataScientest. There's everything in English. The sources provided. Yeah.
There is one question actually. So is it easy to update a Python code with PySpark? Let's say I made a project with only classic Python library, and now once the project is finished, I would like to use Spark.
There are some similarities. So you can use Python programming, but then Spark you need to install a different library. Also, as you have seen below, it's a combination Spark, and then you have a Python wrapper around. So first you have to install Spark. For Spark you need Java normally, and then once you program, it's also a little bit different syntax. So you have this large scale data frames. They are RDDs. I think here I showed a little bit about them underlying because it's decentralized, and the data frame normally it's in your laptop. And what you could do is to take out a small data frame from Spark data frame, which can be 1 petabyte of data. It can be really huge data. You take out a small subset and analyze this with normal Python libraries locally on your laptop. But if you really want to code these to get data out, then you should make a PySpark course. But it will be easier, of course, if you know Python. But it's not just an update. It's not the same code. It's a little bit different and in the syntax. Also, if you have this streaming from Kafka, the two options, you have a normal Python streamer with small data. This, yes, you can just use with the DataScientest project. You can query, I think it's Kafka, pip install. Kafka, you take a consumer, but then you don't have the scalability. So once you want the scalability, you need to use PySpark, and then it's a little bit different syntax, but normally it should be not such a big deal to jump in. What is normally in PySpark a little bit confusing is this lazy load. So if you debug it, you see the bug only later. So it doesn't tell you now here's the failure. So it's executing all the code at once, and you don't find maybe where the error is. So you have to add print statements or collections. But yeah, this a little bit you need to learn about PySpark. It's not out of the box. Then Kafka. No, here, yeah. Kafka integration, intermediate step between Kafka producer and Kafka consumer. Script of Kafka, demo plays the role of brokers and topics. I think, yes, you have the Kafka is the in the middle, then you have a producer, which is API call, which is installed maybe locally. You just call it and then connecting to the Kafka cluster, and also the consumer. You gave in this IP address. I think here it was local host. No, locally you installed a Kafka cluster and connect to that one.
Okay, so I don't think there are any more questions.
Is it easy to update a Python code with PySpark? Yeah, yes, this we had. You can make
Yes,
you
yes.
can pip install PySpark. You can do, but maybe you need also the libraries below.
Okay, perfect. So I will share the link to the Datamix website, so you can all check. This check out the website. And regarding data scientist, I already sent the link before. We have some training programs for data engineers and machine learning engineers. So if you want to have some details about Kafka, Spark, or Python, you can check out those particular libraries. And for the moment, I wish you all a good day and thank you again, René and Hira, for being available today for this great presentation. And have a nice day and a good weekend, of course. So, bye everyone, and see you very soon for a next webinar or whatever.
Thanks for the invitation, Dimitri. It was a pleasure to present. Also, thanks, Hira.
Yeah, thank you.